Hello everyone, for this video we're going to talk about areas of sectors and segments of a circle. But of course, let us know what is our learning target for this video. Hopefully after watching this, you will be able to determine the areas of sectors and the areas of segments of the given circles. Now, I'd like you to be guided of the following questions that hopefully after watching this video you will be able to answer or else elaborate the following questions. First, how do we define a sector of a circle? Second, how do we define a segment of a circle? And lastly, how do we determine the area of a sector of a circle? And what about a segment of a circle? Now, first, let us define a sector. Now, here in our illustration, as you can see, the shaded area, this is what we called our sector. Okay, so sector of a circle is the region bounded by two radii of the circle and their intercepted arc. So here is our intercepted arc. Okay, so I'd like to share to you this area of sector theorem. Now it states that the area of a sector whose arc measurement is A is the product of the ratio of A, or the degree measure of the intercepted arc, to 360 degrees and the area of the given circle itself. Okay, to make it more precise, this would be our formula to find the area of a sector of a given circle. So, degree measure of the intercepted arc divided by 360 degrees multiplied with the area of the entire circle, which is pi r squared. For our first example, find the area of the sector EQS. That means we are supposed to find out the area of this region, this one. Okay, so of course we are going to use the formula stated before. So area of a sector is equal to degree measure of the intercepted arc divided by 360 degrees times the area of the entire circle. Now, of course, let us start substituting in our formula. For our intercepted arc, this is 30 degrees. So, here in our illustration, we have the intercepted arc ES, which is 30 degrees. So, that's why we have here. And simply copy 360 degrees times. So, pi, I'm gonna substitute the approximate value of pi later on instead. So, I'd like to focus first with this radius. So, given our radius is, here in our illustration, the segment QA is 40 meters and this is our radius. So, substitute 40 meters. And don't forget the square. Okay, now let us simplify first the 30 degrees divided by 360 degrees. We all know the GCF of 30 and 360 is 30, or else we can say that 30 and 360 are divisible by 30. So 30 divided by 31 and 360 divided by 30, we can have 12. And then I'm just going to copy the pi first, and 40 meters times 40 meters. So we can have 1,600 meters squared. Okay, next is, let us multiply this 1 over 12 to 1,600 meters squared, or we can proceed with multiplying it as well with our pi. But let's start doing this by 1 over 12 multiplied with 1,600. So we can have 1,600 over 12. I'm just going to copy first the pi and then meters squared. Now, we need to, as recommended, we are going to multiply 1600 over 12 with the approximate value of pi, which is 3.1416. So using your calculators with you, we can get area of a sector is approximately equal to what? Okay, so our answer for this item is 418.88, and let us not forget the unit of measurement, so meter and then squared. Therefore, our final answer for this problem is 418.88 meters squared. Okay, next. So we have here, find the area of the shaded region. As you can see here in our illustration, the shaded region is considered the major sector of the given circle. Now, do not get confused because we are going to use the same formula that we've used before. But before we proceed to that, let us analyze first the given data. We are not supposed to substitute the 40 degree measure of the intercepted arc for this formula because, as you can see, the 40 degrees is the degree measure of the intercepted arc of the unshaded region. But this time, we are asked to find the shaded region, which is the major sector. So first, we need to find out what is the degree measure of the intercepted arc of this major sector or the shaded region. So we all know the entire circle, the degree measure of that is always equivalent to 360 degrees. So we will deduct it by 40 degrees, and therefore we can now use 320 degrees to substitute for the value of A, or the degree measure of the intercepted arc of the shaded region. So now let us substitute already. So we have 320 degrees divided by 360 degrees times pi, and our radius is 15 meters. So we may substitute this already, squared. Okay, now let us simplify first 320 and 360 degrees. So we all know that 320 degrees and 360 degrees are both divisible by 40. And now 320 divided by 40, we can have 8. And 360 divided by 40, we can have 9. And then, let us simply copy first our pi, and 15 meters squared, so we can have 225 meters squared already. Now, before we multiply, we can cross multiply this to simplify, because as you can see, we do have this fraction 8 over 9 multiplied with 225. So we can simplify further already by using cross cancellation. So 225 and 9 are both divisible by 9. So 9 divided by 9, it would be 1 already, and 225 divided by 9, so we can have 25. So it's simplified already. Now, let us proceed with the multiplication already. So 8 times 25, it's 200. And our denominator is 1. 1 multiplied to the denominator of 25, since it's a whole number. So expected that the denominator of this will be 1 as well. So 1 times 1, 1, or no need to write it. And simply copy the pi. And this is not yet our final answer. We need to multiply it, the 200, with the approximate value of pi that we are using, and that is 3.1416. Therefore, our answer would be area of the given sector is approximately equal to what? 628.32 meters squared. By the way, we are rounding off our final answers to nearest hundreds always, and Take note that it is not proper if we are going to round off the values in the middle of our computation. Better if we round it off always at our final answer so that we can get almost the closest answer that we can have. Okay, or the most accurate answer that we can have. Okay, Next, we have what if you are going to find the degree measure of the arc of the sector whose area is 90 pi centimeters squared if its radius is 30 centimeters. So this time, the area of the sector is already given. You are going to find out the degree measure of the intercepted arc. So of course, we are going to stick with our formula for area of sector. And let us manipulate this through the given details that we have. So area of a sector, so let's substitute. So 90 pi centimeters squared equals. So A, this is what we're looking for. So just simply copy. So 360 degrees times pi. And our radius is already given, which is 30 centimeters squared. Okay, now, so let us simplify first. So 90 pi centimeters squared equals. So I'll just simply copy this for a while. Okay. So let us get what is 30 centimeters squared. So we can have 900 centimeters squared. Okay. So this time, let us process first the right side of our equation. So as you can see, we are going to multiply A over 360 degrees with pi and 900 centimeters squared. So before that, we can actually cancel out or simplify already 360 degrees and 900. So as you can see, 360 and 900 are both divisible by 180. So we can simplify it already. So if we're going to cancel this out, so 360 divided by 180, so we can have 2. And 900 divided by 180, so we can have 5. Now, so let us multiply it already. So A times pi times 5. So we can have 5 pi A centimeters squared. Okay. Then next is, of course, our denominator. So 2, and of course, since it's a whole number 5, the denominator there is 1. So 2 times 1 is 2. So 5 over 2. Okay, now, of course, next would be, since we do have our fraction here at the right side of our equation, we can eliminate this one through multiplying both sides by the denominator 2. Okay, so let's make use of our shortcut. Okay, so multiply again. So both sides of our equation by 2. Okay, so that means we can cancel this out already, and therefore we would have so 2 times 90 pi centimeters squared, so we can have 180 pi centimeters squared. Okay, next we have okay, so we have here 5 pi A centimeters squared. Okay, now, so our target is to find the value of the variable A here. So next is, let us isolate A here at the right side of our equation by dividing both sides by 5 pi centimeters squared. So 5 pi centimeters squared. So we can cancel this out already. So 5 divided by 5, 1. Pi divided by pi, 1 as well. Centimeter squared divided by centimeter squared, cancel out as well, or 1. Okay, so that means the remaining expression or term at the right side of our equation is letter A, and at the left side of our equation, so we can cancel this out as well. Centimeters divided by centimeters, so it will be 1, or no need to write. Pi divided by pi as well is 1, or no need to write. 180 divided by 5, it would be what? 36. Okay, but of course, since we're talking about degree measure of the intercepted arc, so it should be complete, we need to put degrees. So 36 degrees is the measure of our intercepted arc. Next, let us talk about the area of a segment of the given circle. First, let us define what is a segment of a circle. It is a region formed by an arc and the chord having the same endpoints as the arc. So let's have this. So as you can see in our illustration, this shaded part here in our figure, this is considered the area of the segment. So now the question is, how are we going to solve for the area of a segment? Now, so what are we going to do is simply subtract the area of the triangle from the area of the sector. So take note, subtract the area of the triangle from the area of the sector. So here, let's try to find the area of the segment formed by the sector CAP and the chord CT. So here in our illustration, the shaded part, this is what we are going to find out, the area of this shaded region. Okay, so of course, let us write first our formula as mentioned a while ago. So to find the area of the segment, we can have area of the sector deducted by area of the triangle. So of course, let us recall first what is our formula again to find the area of the sector. So we do have A over 360 degrees times pi r squared. Okay, so let us have this one, and then deducted by what is, or how are we going to find out the area of the triangle? So what is the formula? So we do have 1/2 base times height, or others might be using B times H divided by 2. It's the same actually. Okay, now, so maybe let us have extra space for that. So let's solve first for area of our sector. Okay, so for area of our sector, our formula again is A over 360 degrees times pi r squared. Okay, so we have here, substitute our intercepted arc as given here. Since our central angle, so as you can see, we do have here perpendicular segment. So that means we do have this 90-degree angle. So therefore, since its central angle, its intercepted arc as well would be 90 degrees. So 90 degrees over 360 degrees times pi, and our radius is, as given here, we do have segment 80, which is 8. So 8 squared. So simplify first, 90 over 360 degrees. We all know they are both divisible by 90. So this is 1/4 times pi, and the 8 squared, that is 64. So by the way, you may write your unit of measurement here in the middle of your solution, or else you can write it at your final answer. It's okay, as long as don't you ever forget the unit of measurement in your final answer. So now, what is 1/4 of 64? So 1/4 of 64 is 16. So that means, so 16 pi. But of course, we need to simplify this by multiplying 16 to the approximate value of pi that we are using or considering 3.1416, and therefore area of our sector is approximately equal to 50.2656. We are not allowed to simplify it first since we are not yet in our final answer. So let's proceed first with the area of the triangle. So I'm going to write it here. So area of our triangle is equal to 1/2 base times height. Now here, how are we going to identify our base and height? So since it is a right angle, it's a right triangle rather, so that means it would be easier for us to find the base and then the height. So here we all know that the segment opposite to our 90-degree angle is always considered our hypotenuse. And therefore, the remaining two legs would be our base and then our height. So let's say this would be our base, this would be our height. And now, if we are going to get confused of this, so like for example, this would be segment CA will be your base and AT will be your height. It doesn't matter in this figure because as you can see, AT and AC are both a radius or radii. Therefore, they do have the same measure. If AT is 8, therefore AC is 8 as well. So here, we are going to substitute B is 8 centimeters and the height is 8 centimeters as well. So now, what is 8 times 8? So it's 64. Okay, so now what is 1/2 of 64? So area of triangle is equal to 32. Okay, so now we do have here our area of triangle, which is 32. Okay, so of course we are going to write our unit of measurement here. So it's centimeters squared, but maybe it would be more necessary if we're going to write it here in our final answer. So here, substituting again, since we do have our value already, or the area for a sector and area of a triangle, we can now substitute it here in our formula. So area of our sector is 50.2656 centimeters squared minus our area for triangle is 32 centimeters squared. Now let us just subtract these two areas, and there we would have area of our segment is approximately equal to 18.27 centimeters squared, and we are done already. This would be our final answer. Area of the segment is approximately equal to 18.27 centimeters squared. Okay, so I'd like you to try this. Find the area of the shaded regions in each figure. Now, you may pause the video for a while, and if you are done answering these two items or these two problems, you may now resume watching to check your answer. So now this is our final answer for this activity. So for the first figure, the area of a sector is approximately equal to 50.27 square centimeters. And for our second illustration, we do have area of a sector is approximately equal to 75.40 square centimeters. Okay, so that's it for this video. Thank you so much for watching. I do hope you learn about area of a sector and area of a segment of a circle. So see you on our next video lesson, and again, thank you so much for watching.